Did we get a recording? There we go. Hey, welcome everybody. Good to have the gang back together. I like to start with intros. If anybody's got anyone that hasn't been with us before or has a new project that they want to talk about, we always like to hear what everybody's up to. Any newbies? Has anybody IPO'd and recently come into tens or hundreds of millions of dollars? There are many of us on this call that would like to chat with you about what you're going to do with all your newfound money. No one? Ah, all right, it was worth a try. Maybe next month we'll get some deca millionaires on board here that they're feeling loose and free with their investment dollars. How about events? We've got let's see, with it, Vertical Flight Society has its in February has the Phoenix event coming up for transformative vertical flight. That's going to be a great one. I really enjoy that one. Johnny, are you going to be there?
Yep, I'll be there. I hope to see some of the team members there too.
Perfect. Are you going to moderate some panels again?
No, I'm taking it easy this time. Hopefully I don't get volunteer last minute.
Yeah, well, that's I'm here. I'm always here for VFS.
Yeah,
If there's a call
that's
to
always a
duty.
good event. Yeah, a lot of interesting content and contact actually.
Yeah, yeah, perfect. Hey, Danny, welcome. Are you going to head out to Phoenix this year? I'm not sure if I'm going to be there. Johnny will be there with this action attitude.
Yeah, I do want to go out there this year.
Yeah, me too. Yeah, technically, right. Yeah,
year.
within the next 12 months, but next calendar year, right. Yeah, no, I hope I do too. I need to carve out some time. That'll be a good one. Any other events that are on the horizon that we should be aware of or that
Well,
people have recently
CES
gone
is
to?
coming in January.
Ooh,
Starting January 7th. I'll be there, but the not dedicated to eVTOL or AAM, but there's always relevant technologies that either on the horizon or newly introduced or maturing. So it's like a treasure hunt for our team.
do they clump like different technology sectors together? Like, for example, would there be an aviation area, or is it just you kind of got to know what you're looking for and
Yeah,
you
I think
wander?
it's like going to the neighborhood garage sale. You have to hunt for it. I did not see a specific aviation group per se,
Yeah,
but aviation is collection of a whole bunch of technology from different sectors. So
totally.
that's maybe what we have to do. Let me also bring up the next week's TVF public service working group meeting. It will be regular time Thursday next week, December the 19th. We'll have very interesting speaker, Rui Marcelino. He's the founder and CEO of Elma Design. The topic really is he's going to talk about a project they worked on together from a collaboration of different organizations in Europe. And his perspective focus of the talk is more on industrial design aspect of the eVTOL AAM industry. So yeah, anybody who have the opportunity, time, please join us. It's next week, Thursday. It will be 2 hours later than this one. It's 11 a.m. Pacific time. So it'll be great to have as many people listening. I went through his presentation. It's very good, very interesting. A little different way of designing things. Worthwhile to listening and chat with him, collaborating.
Yeah, cool. That'll be a good one. I'll look forward to that. What else is on the horizon? Good, bad, ugly, terrifying, thrilling.
No caller.
Gaylord, you might want to mute.
Yeah, I got a problem here.
I'm gonna mute right now.
Perfect, perfect. Yeah, and if any other comments or ongoing activities or events that we should know about before we jump into hearing from our speaker?
Aren't the NASA SBIR announcement coming up?
That's a great point, Todd. They absolutely are. I think usually the first or second week in January. Is that right?
Something like that. I haven't looked at it recently.
We had Bruce from NASA join us last year to give us an overview, and I pinged him again this year to say, hey, could you jump on with us? And that brilliant man is retiring. So
Yeah.
I think he's working on, yeah. So that's exciting for him. I really like Bruce and I really have enjoyed working with him. So, but I think he's going to have more fun doing what he's going to do next. But I don't know who his successor is yet. And he was going to see if there was a way to figure out who that was and maybe link us up. So that's something that we're working on. Johnny, do you have any insights there?
No, I had the same question as well. So it would be good to have whoever's pick up the baton to
Yeah.
give us some update. Yeah, that would be great.
Yeah. I bet there's some good stuff there.
Would be curious if anybody who went to the Revolution Aero, how that went.
Any attendees? Great question.
Which one? I'm sorry.
Revolution.aero, was that out in San Francisco again this year, Danny?
Yeah.
Yep. He says yes. I didn't make it. That was a little outside my wallet size. I'm just a poor man from South Florida trying to give back.
There's one more meeting coming up, SciTech, AIA SciTech meeting. It'd be January 6th to 10th in Orlando, Florida. So, hey, neighborhood meeting. That's always a in-depth technical meeting. I try to be there whenever I can, but this year it's exact same time as the CES. So I had to choose.
CES, it sounds like it'd be a little more fun.
Yeah, the fun factor, yes, absolutely.
I've never been to that one. I would really like to go. It sounds kind of bonkers.
Yeah, but if you like the in-depth technical discussion on anything that flies, yeah, SciTech from AIA is absolutely, from time to time, should be there. Yeah.
Perfect. Okay, good one. Good to know about. Thank you, Johnny. Anyone else? Anything interesting going on? Any events? Birthdays, bar mitzvahs? I'm gonna then introduce our speaker. And before I do, I wonder if everybody could mute, and I'm gonna do the same thing in a second, so we don't end up hearing our dogs bark when Damjan's trying to show us some slides. So we've got a really cool and brilliant speaker with a fantastic background. So I think this is going to be one of our greats, and I'm really glad that we've got Damjan Zabovnik with us today. He's got a brilliant and varied background. He's a physicist, an inventor, and athlete, and he's in his previous life worked on breaking the land speed record for human-powered transportation in these really amazing recumbent bicycle streamliners that he professionally rode for years to break speed records. And I told him, we talked about this. I said that's as interesting a story as anything. So if we have a little bit about that and a little bit about the aircraft that you're working on, I think we're going to have a really fun talk today. So he's a lead designer. Yep. At EIVIE, working on software coding, the UAV systems, and a whole lot of aerodynamics and computational fluid dynamics. Damjan and I met in a little bit south of San Francisco, and we ended up meeting at what is a hangar and bike shop, and it was sort of a confluence of all of our interests. And we got to chatting, and I was very grateful he was able to join a group. And now today, thankfully, we'll get to hear a little bit about his work and what brought us here together. So, With that, I'll mute myself as well, and the floor is yours, Damjan.
Thank you so much, Andrew, for nice introduction. I'm Damjan Zabovnik. I'm gonna share my screen, not to waste too much time. Here we go. I hope you see it well. So I'm founder and CEO of EIVIE Corporation. We are established for good 2 years now, prototyping for good 3 years. It's the next generation eVTOL, and many say that drones are future in aviation in many sectors, and we believe that this design is the future for the drones. So we started with the aim to make a one-person transportation vehicle, like flying car, similar, and attended Go Fly Personal Flying Device Challenge competition almost. It ended before we entered, but preferred propulsion are electric motors, and it can support manned transportation or goods, or you can use it for viable aerial services with drones, autonomous, and so on and so forth. So this is the competition I mentioned. Boeing was main sponsor. Speed was important to achieve range, endurance. Size of the aircraft needed to be below 8.5 feet. You needed to lift one man with that. Requirements were really high, 200 pounds, and I think around 6 feet tall man should fit inside. Noise was limited really strictly, and visibility needed to be good. So I realized, Arthur Ciordia Sr. inspired me to go for it. I realized that I had some design already on my computer that we could use. But let's go to my past first. And this is a recumbent bike I built and traveled with them a lot around Slovenia, Europe. This path later led to selling some of them and go for speed records. This picture is taken in Slovenia around 2007. This is a group of cyclists, my brother on the right and two friends next to me. I'm riding a little lower bike because I was already training for world speed records at that time. This is around 2010. In 2001, I won the biggest race in Slovenia. Around 3,000 amateur bicyclists attended, and I had a recumbent bike. I cheated a kind of with aerodynamic, fairings around and body sock. You'll see a video in short time here. And this is the bike for speed challenges later. And the biggest speed was 80 miles an hour in 2015 in Nevada. So to go forward, this is EIVIE 1 built in 2002, and we were in Nevada first time in 2003. It was built for another man, best track record rider in Slovenia. This is EIVIE 2 built for me in 2005. I went to Nevada again, trying how much faster I can go. Previous year, in 2003, I went 68 miles an hour, and then in 2005, I went around 72 already with this new bike. The same bike in 2009, I set world record in 200 meters flying start. Let me expand this back to full size. So it was roughly 66 kilometers, 67 miles per hour speed, 107 kilometers per hour. I went to London with this bike to Science Museum at some point and present it for 3 days. Next to my bike was Jason Quelly. He's gold medalist from track from 2000 Sydney Olympics. His bikes were on display at the same time. This is EIVIE 3 in 2010, way more aerodynamic, more laminar flow was used. And I contributed to the world record of another guy who made the world record in first attempt in 2011 with copy of EIVIE 3 you just saw on previous slide. Here I am in 2015 with EIVIE 4, which had really low air drag, extremely laminar flow and very small. You can see how small it is compared to my body size. I got a Calfee design for sponsor who I worked for later for 4.5 years. And Joby in 2014, I made a connection and they sponsored me. My biggest sponsor in my career was a mobile operator from Slovenia. That year was really stressful. It was the only year that I couldn't really go fast because the bike experienced some oscillations, which I solved. Next year in 2014, I already went almost 80 miles an hour with the same bike. But in 2013, only 40 miles an hour. I had many projects in my life built from scratch, like electrolyzer for a car. I separated hydrogen and oxygen, added to the fuel mixture to improve efficiency, and the engine runs more cold and for a longer time. On the right, you can see vertical windmill I experimented with. I built a hut, which is about efficiency as well. So this is, it is 8 inches of styrofoam on the walls, and it's truncated icosahedron. I purchased a piece of land in the middle of nowhere in Slovenia and put this there, and hunters were not very happy about it, but I became a hunter later and they tolerated me. This is in the winter, and basically 2 people can sleep inside and with body temperature only heat the place. But I had a little propane heater as well for emergencies, and I could cook. So it was quite an experience. Sometimes I skied there, Nordic skiing, when it was snow like this or even more snow. Almost finished the same cabin in spring 2011. I equipped it with solar panels on top of the tree. That was a challenge. You can see on the left hut below the cabin, and on the right how it looks from the top of the tree. I built those solar panels from scratch. I bought cheap cells and soldered everything together. It was around 400 watts maximum power. From EIVIE 1 that you saw before, I had plans to make an electric tricycle who would be in regular traffic to have really good range. And I never did this, but maybe one day I will. In around 2009, 2008, and 2007, I met Dick Fradella from South California, and I visited him. Here on the picture you can see 2 inventors and me, and I then tried to make a more efficient, better flywheel. He was working on magnetic bearings, and I tried the same. I built my own prototypes and later met them again to show them what I built. It didn't go very far. Some things were patented already, and no, never mind. I got 2 patents recently in USA for hydrofoil propulsion. using linear electric motors and special linkages that enable linear motion. One foil would go up while another down, and it's reciprocating movement. Now, if we go more into drones, my basic idea is to solve the traveling issues. There are traffic jams, not very pleasant airports, as we know, bad weather sometimes, potholes, sinkholes, I mean, and flooded roads. This on the right top was pictured really close to our home, close to Watsonville, California. Here is where we can use drones, as you know, for firefighting or law enforcement, land survey, different inspections and monitoring in agriculture. So I chose those because our drone can carry a lot and is fast and so on. You will see later. So we are unique in a way that we think out of the box. I started with recumbent bikes back in '89 and built my own one. First one was with head first and drone position. So the point is, these bikes are way faster than road bikes. Aerodynamics, you will see later on a slide, is 20 to 40 times better than a road bike aerodynamics. And you know how bicycles began with one big wheel, very high center of gravity on the top picture you can see. And maybe VTOLs have a long way to go from beginnings that are now to what will be in the future. This record, so you need to build up speed. And another record I already mentioned in 2009. So this guy on the right was world record holder in 2011, and he improved his record in 2016 with the copy of EIVIE you can see on the picture below. I'm still actual fastest man on the earth, over 40 years old. That was in 2015 when I was 80. Went 80 miles an hour, actual fastest designer, builder, and racer in one person. And yeah, that's it. This is about efficiency. We did computational fluid dynamics for many of these iterations. EIVIE had 0.0083 square meters CDA, which is awesomely good. It happened only one early morning when the air was not moving, so laminar flow was really working. Despite cold temperatures, it worked really good. Otherwise, it was like 20% more air drag if it was more turbulent air. Anyhow, you can see we had it on wind tunnel, Francesco's EIVIE bike, and it performed 20 times better than a road bike. And if we electrified EIVIE, for example, with 1 gallon volume lithium battery, EIVIE would cover 370 miles, while road bike only 55 miles, not 55, 24 miles, with both going at 55 miles per hour. So this is big difference. I will show you a video about developing drone that I'm talking about. So all my knowledge from aerodynamics I'm using here. And you know why the wing is circular? Because I used to ride bicycles. So that's self-evident. No, it's really for compact wings and be small while it can still carry a lot of weight. Here it is in a painting booth in the building where Andy was, where we met. And this is GoPro camera, first time used. So we have this runway at Monterey Bay Academy, and we could technically even fly over the ocean, which I'm not practicing because sometimes the drone falls down when I don't want to. I'm on the tree here. These were first trials of vertical flight, and then untethered, first time here inside painting booth. And first time outside untethered. We had some wind here. Tuning is not best. The drone was around 7 kilograms. At that time, I used crane to tune it better. We had many iterations. This is one of the first ones. Prototypes are ugly and just proving the concepts. There is elastic, so it's almost free, not quite. This is first flight outside that I am piloting remotely, and I almost crashed here. So the learning curve was really steep, but I had to try it. And successful landing in the same flight. So we tried higher center of gravity and less vibrations. And we tried more center of pressure higher. That's why I built that box out of sheets of foam, which proved to be good, but unuseful, of course. So we kept brainstorming how to keep aerodynamics and have good stability. So finally, we got rid of the lower control surfaces. This is one attempt of perimeter control surfaces. Perimeter, yeah, or you can call them periphery. This is Y configuration and first attempts of transition. And a little better flight. Our test pilot here. You can see additional control surface for pitch in the back. So I've tried many things. And then from a little more complicated and uglier, we got it to more simple, more stable, and nicer and faster design, which is here. First time with 2 motors in the back and 2 motors in the center, no control surfaces under the main propellers. And these are first attempts of transitions inside the building. And a little faster, the same thing. Okay, now I need to go next slide. We did analyze, we analyze constantly vibrations, tuning, different things. This is from flight controller, but I also am recording by Arduino board. And these are motor power. On this graph, we have 4 motors on periphery and 2 in the center. I have another video. So this is the bike, yeah, and the drone now can fly in all flying phases. This is transition back to vertical mode and landing. So this is a good union of coaxial helicopter and fixed wing VTOL. It has all good stuff from both designs. Problem today is that wildfires are more and more frequent in the last 10 years alone. In North America, they cost damages and they, 10 billion, $56 billion of damages and costs they caused. And firefighting drones today, the ones that can carry a little bit more are not too fast. I'm talking about multicopters mainly. And they have shorter flight time and range is not that big. If you have fixed wing VTOL, which can go further, they cannot carry that much. But we are aiming to go 100 miles per hour and cover 1,000 miles in one flight using gasoline, which is, we know, 54 times more energy dense than batteries. And payload capacity could be around 500 pounds. I'm talking about drone that is bigger, around 12 feet maximum dimension. And there is bonus solution when you are small and heavy, the wind doesn't impact so much. So it's pretty much wind resistant, which comes useful in firefighting again, because wildfires themselves create winds. So solution is to reduce damages and costs of wildfires, early detect from the same drone that has deterrent on board already, and is the closest to the wildfire that is just being detected and goes to the scene and extinguishes it immediately. We can also have drones that only monitor and those that only extinguish, but it's useful to have all-in-one solution as well. So we are contributing to sustainability a lot with cleaner environment. So this is the drone that would extinguish. It could scoop water from lakes if it flies horizontally, or from small surfaces, it could land on them like pools, whatever, and snorkel out, yeah, and then carry it to the fires and continue doing this back and forth. That's why the propellers are on this version above the fuselage, so it can take off and not touch the water with them. So multicopters on the left two columns, they are not too fast. Helicopters in the middle, they cannot operate cheaply. We know flight hour is around $3,000, probably more today with inflation for them to operate. And maintenance is expensive too. And we know there is lack of pilots for them. Fixed wing VTOLs can't carry much and are not that wind resistant. And if I make usefulness index for our drone and other VTOL common designs, that's speed times carrying capacity divided by cost. EIVIE really sticks out here. It's still simple design, but useful and capable. We are aiming to service first with our drones. We would do pilot testing in firefighting, or we could do long range monitoring over the ocean. Later, when the design proves itself, we would manufacture more of them, contract out manufacturing, probably lease them and sell them. This is our core team. I'm an inventor and physicist coming from Slovenia. I live here from 2015. the whole family came to find new opportunities here, and we are citizens now after 9 years, all of them, all 4 team family members. I got a visa based on special achievements, extraordinary abilities. So it was EB1A as scientist and athlete. Arthur Sordia Jr. is really good, a remote pilot who used to fly for SpaceX around airships to monitor insulation tiles, and worked with NASA and all branches of military. He has more than 4,500 flight hours, I think. His father is a good aviation designer and pilot of fixed wing aircraft and artist. Jose Aguilar is agricultural expert. We wanted to go into agriculture, crop spraying first, but he is also a remote drone pilot. He used to do that over agricultural fields, and has experience from that. Our advisors have complement us well. There are scientists, experienced startup advisors. Shao is Rotorcraft pilot and fixed wing pilot and CEO at Friendly Robots, PhD engineer. I attracted an expert from long range logistics, Michael Hill. Todd Bressler is a forged entrepreneur and inventor, and I have a marketing guy. We have him. Matthew Weaver also was involved in human-powered vehicles, and he was pioneer in laminar flow back in 2000. And also, he made first camera bike with monitor inside, so he had no windows and no mirrors. By the way, when I competed, all of my bikes went on 2 wheels, and going backwards, I used, and Francesco Russo used, a mirror to see the road in front. So we were another specialty in this sport. But today's world record in 200 meters flying start in Nevada is made with very similar bicycles that Matt Weaver envisioned back in 2000 and even before. So our drone can be on demonstration now. We can show all flying phases. It's at technology readiness level 6 in this regard now. We take care for intellectual property rights, and we have that private testing runway you could see. We join our forces in networking. And here's another video that is more recent too. Some of this you have seen, some are new. We are working on making better resolution videos soon. And making them more professionally. This is how it would be used for crop spraying. So this is all recorded in vertical flight mode. But of course it could fly on the wing and go way faster. So we have either 6 motors or 4 motors. On this video, you can see 6. It improves stability. but at the same time you gain some weight and aerodynamics is not so perfect. I did all flight modes in both variants of this drone. So you can see how fast it can go forwards and backwards. It can go around 30 miles an hour, 15 miles an hour sideways because you get more air drag that way. And we are talking about 3-point-feet size drone. Anything bigger would be even more wind resistant and fly nicer. Okay, I'm gonna discontinue this. How are we on time?
We're doing good. We have about 15 minutes left, and
Okay, maybe I leave another 2 minutes. I recorded almost anything that we ever tried, but not all, not everything.
the
I will
your
not
aircraft.
show you the hardest crashes we experienced. That's for sure.
I can tell you the
you,
aircraft looks incredibly agile and
Mhm.
slippery. It's very fast.
Yeah, I used laminar flow on fuselage. We can improve that even more. We can make fuselage wider and taller if there is more need for carrying bigger, goods that don't have that big density. But this is something I will do for one-person aircraft. It would look like this. So, the man would be in prone position inside to see really well from in front and downwards too. On this video, you can see first time I'm landing on a pickup truck. That was a challenge. And it spontaneously happened. So I'm learning a lot. Many people can fly better, but there's no LiDAR on board right here. And no airspeed sensor. We are getting there soon. It will improve from here. So next slide. We could inspect offshore windmills or wildlife. We got a letter of interest for this as well. So 5 years before these offshore windmills are built here in California, they need to monitor wildlife, how it's doing, and then during operation again. Also, we could supply oil rigs because our drone can fly efficiently long distance and carry a lot. And it makes more sense to use a smaller drone in many cases than to use a helicopter. So our go-to-market strategy is to provide services first for wildfire detection and extinguishment in California. This is general. Drone service market size is huge. It's even bigger than manufacturing, and selling part of this business. So it can grow to roughly $94 billion size globally by the year 2030. I'm gonna talk briefly about effectiveness and persistence, which is important for any field, for any project. Jason Quelly, you saw in that science museum in London, his bikes. gold medalist, tried to go fast too. He had engineers from Formula One and budget of €500,000. He came to Battle Mountain, Nevada only once to try how fast he could go. They all wanted world speed record, but they went only 64 miles an hour and never came back. Matthew Weaver was way more persistent, but especially more effective. With laminar flow bike, he could go 78 just the same year, basically, yeah, in 2001. 2 years later, I went 86 miles an hour with too big of a bike. You can see my pilot launching me there. He was way stronger than me and taller for a couple of inches. He was, I think, 5 inches taller than me. So bike was too big. And with EIVIE I reached 80 miles an hour after 13 years of trying, and I got 2 world records. Thank you for your attention. I think I'm gonna use my determination in drone business and development as well. So let's see how far we can go. We are fundraising over Start Engine beginning in January, and I welcome you to contribute generously. You get common stock of EIVIE Corporation and make things happen, really help to make a change in the world, I would say. Do you have any
Outstanding.
questions? I'm happy to answer anything.
Yeah, fantastic presentation. I love your whole backstory, and I can see it really did translate to your aircraft in terms of its aerodynamic and agility capabilities that you've designed into it. So while other people are thinking of questions, I have one, which is, how did you replace the control surfaces or relocate them? And if this is a design in-house design secret, don't spill any beans, but to the extent that you have publicly available information, I'd love to hear how you did it.
I
It's
can
really
say
cool.
definitely that I always wanted more simple, more lightweight, and more fast-looking aircraft. And as you could see from that video, from trying many stupid things, but they helped us, of course, we came to something that I'm really happy about. It's only 2 servo motors and at least 4 electric motors, and you have all control you need. And it can emergency land as well as fixed wing aircraft. So you don't see wheels, but there are some skates, I would call them, little feet on the bottom of the winglets in the back. And before you really stop on emergency runway, let's say, you have nose up, so the front leg is not such a concern even if it breaks. Having no wheel, I'm talking just about emergency landings. If the man is on board or valuable equipment, of course, there can be also ballistic parachute. But yeah, inverted V configuration for control surfaces gives you really nice flying characteristics. When you do roll, it automatically influences yaw as well. And that's something that is very natural. Even when you look this aircraft flying, it's something that looks stable all the time, I think.
It sure does. It sure does. What other questions do we have out there?
I was just going to ask, when would you get around to trying with the lift rotors on top?
Let me add something that Arthur Ciodia Senior contributed, details like inverted V. He is good aviation designer. But to this question, why are rotors, not rotors, they're propellers, they don't change pitch. They're on top because if you go for firefighting and you want to replenish water on the aircraft, you would use lakes or pools or whatever is available in the near. And if the rotors, if the propellers were still on the bottom of the fuselage below, it would go in the water, and maybe that would not be easy then, especially if you scoop water. You don't want to go with propellers under the water, right? You just want to go with the tip of a tube inside, so it's water is collected by pressure and speed, relative speed to the water surface. Otherwise, I would prefer to have propellers below because it's more efficient. The fuselage is not in the way. Fast speed from prop wash, fast speed air from prop wash goes directly down and does its job for high thrust upwards. I hope I answered your question.
Yeah, excellent. What other questions are out there? On the topic of using water or fire retardant, would you adopt a similar design for your agricultural spraying aircraft? Would it
Yes,
also
but
be?
I would keep propellers below fuselage there to have
You
better
would?
penetration. Oh yeah, the spraying nozzles would be just below those two coaxial propellers, counter-rotating, and would really penetrate well into crops. Some crops need that, like Brussels sprouts or artichokes and similar.
So the downwash is part of what's going to distribute the fungicide
On
or
the
fertilizer
vineyard,
where you want it.
on vineyard, for example, you want the whatever they spray, you want it on the bottom of leaves as well. So it's really important. It reaches the ground, bounces back up, and makes turbulences, you know, with all those nanoparticles, microparticles. So the idea is to spray in agriculture as precise as possible, to spray only where needed and nowhere else. Even the drone could be just the size of a row of some cultures. So you don't spray in between on the raw soil and you don't contaminate environment so much. So that's another sustainability mission we could have one day, to spray efficiently with low concentrations, just what's needed, and keep our food more healthy. And also underground water and soil suffers from all applications.
Mm-hmm. What other questions are out there?
Hey, did you,
Johnny?
from the videos, I can't quite make sure for sure. Did you end up with 4 smaller propellers, or did you end up with 2?
So
as your
I hope
preferred
I
design?
will, yeah, I am at 4 right now, but I hope I will end up with 2 only. As I mentioned, it's bigger weight and less aerodynamics if you use 4 outwards propellers. But I will, of course, keep 2 big ones for big carrying capacity, high thrust, and at least 2 need to be in the back for horizontal flight to push aircraft forwards. But CG, center of gravity, changes for these 2 variants. As I told you, I tried both of them and they work. I had some issues in the development, so I added 2 in front just to expedite, to go faster into full flights, reliable full flights, I would say.
Gotcha. Thank you.
We
You're
have
welcome.
3 minutes left. Time for another question or 2. I'll throw you a quick one, Damjan. When you think about manned operations, what kind of applications come to mind? For me, the first one I think of is the emergency medical services and public
Yes.
services.
Yeah, very good point. So wherever you need to go fast and land fast, I remember Jump Arrow in this
Yes.
meeting, right? So they can go really fast, but there is one issue. They need to transition with going nose up and increase altitude before they can land. And that time is precious. I'm seeing some drones here used in military where time is crucial too, but they are landing for 1 minute or more. So we can be level throughout the flight and get to the scene really fast because we can transition back very efficiently and land immediately. That's one benefit. So I'd like to contribute to public safety too. Emergency response, search and rescue, and things like that.
That'd be a great one.
Hmm.
You hear that, Johnny?
Oh yeah, always. Dear to my heart.
Perfect. All right. Well, Johnny's always a great advisor on anything to do with public services and emergency medical and disaster relief and so forth. So stay close with Johnny. He's a good coach on that
Definitely.
topic. Yeah.
I'm trying. Thank you.
Perfect. Perfect. We just have a minute left. Any other notes or questions? Ben said, great presentation, thanks. And Dr. Bevel said, thank you, Damjan, very interesting. I have to leave. And so everybody appreciates it, as do I. This is a wonderful presentation. And
Thank you.
I see you going nowhere but up, literally and figuratively.
Thank you all for your attention. And yeah, please remember, fundraising.
Yes.
Crowdfunding.
Perfect. Perfect. All right, I'll send everybody your website.
Thank you.
Thanks for
Have a
being
good
here.
one. Happy
Thanks all.
holidays, everybody.
Same to you.
Thank you much.